Okay, I think we're right on time. I'd like to welcome everybody to getting into the weed seminar series, Farming in a Humid Year. Today's topic is fundamentals of fungicides. My clock says it's 12 o'clock, so we'll ease our way into the seminar with some housekeeping chores. For everyone not familiar with Perennia, Perennia is a multifaceted company servicing food, beverage producers from field to fork. This workshop is our third session of the third season of our winter webinar series, Getting into the Weeds, hosted by our agricultural service team. Sessions like these are part of our extension program. We develop workshops and other training, as well as offer production advice, in-field disease and pest identification, management advice, and help addressing emerging and critical industry issues, and helping producers be environmentally and economically sustainable. Part of our ag services also includes our field research team. We offer comprehensive trial and research support on contract. For today's Zoom webinar, all participants will have their audio and video turned off during the webinar, just to keep down distraction. Please make sure the name displayed in the Zoom matches your pesticide license name. You can change your Zoom name by right-clicking on your picture or icon. If you'd like to ask a question, please use the Q&A feature at the bottom of your screen. Please keep an eye on the chat function, as some links will be posted for pesticide points, etc., in the chat function. We will be monitoring the chat and Q&A throughout the session. Questions will be addressed at the end of the presentation. Hugh, our low bush blueberry and cranberry specialist, is co-hosting with me today to keep me out of trouble and to make sure things run smoothly. Hugh will be monitoring the chat and Q&A box. This session is worth one pesticide credit. To get credit for this session, each participant must be watching from their own device. So if you have multiple people gathered around a monitor, some of those people may want to log in on their phone just so that your name shows up in the Zoom participants. Your Zoom name should be the name on your pesticide license. I have posted a link in the chat. Please visit this link, fill out your name, address, pesticide certification number. You must then print the screen before submitting, and you submit by pressing done. Keep that printed copy for your own records and submit that when you go to renew for certification. If you can't figure out how the survey works, please email your favorite Perennia specialist and they will try to assist you. For CCAs out there, you can scan the QR code here to sign in. It will also be available at the end of the session. That wraps up all the housekeeping chores today. Today with us, we have Dr. Jennifer Foster and Dr. Katie Goldenhar to discuss the finer points of fungicides. The 2021 season definitely put our traditional spray programs to the test in many ways, as the season was warmer and more humid than we would have expected. Crops grew very lush with this growth and excellent growing conditions. This also favored disease development. We were challenged by disease showing up earlier and staying longer, as well as some diseases being experienced in crops that we've never seen before. So we thought we'd turn to two great speakers for this week's session. Jennifer Foster is the Agronomic Services Manager at Syngenta. Prior to her current position, she was the Global Technical Manager for Fungicides for Syngenta. She has a wealth of knowledge and real-world experience to understanding how fungicides can be used to manage disease. Katie Goldenhar is the horticultural pathologist at Omafra. She specializes in identification, detection, and management of plant diseases and verifies and validates new disease management techniques and technology for the Ontario horticultural industry. It is also important to note that Katie is also an avid outdoor canoe enthusiast. With that, we'll turn things over to Dr. Jennifer Foster, so we can be better prepared for the cropping season and in 2022. With that, take it away, Jennifer.
Thank you very much, Sunny. I'll just start sharing my screen and pull up our presentation. Thank you so much, Sunny, for the invitation to come and talk. I really love fungicides. So when you asked me to talk about this topic specifically, I think I said yes within 5 minutes. I also like to thank Katie for coming along for the ride. So I reached out asking Katie for some support, and throughout the session, we're going to bounce back and forth. So I hope we don't lose yet, but at the end, there will be time for questions and specific questions that you may have either from last year or this coming season that we are faced with now. So I would like to point out that Katie and I both are trained from Michigan State, and I tried to find a picture of me also in a Michigan State t-shirt, but the best I could do is matching her for being in a strawberry field. All right, so yeah, Katie and I have worked together for almost a decade now in various roles in industry, and as well as her working now in the extension space with OMAFRA. It's been a good ride, challenging each other and the theories and the concepts that we're going to talk to you about today. So what are we going to talk about today? First is around disease management and IPM to make sure we're all at the same level when it comes to those principles and guidelines. Then I'm going to talk about what fungicides do, and in many cases talk about what they don't do. Then do a deep dive into how fungicides work. You know, people like me, I work for a crop protection company, and we throw out a lot of terminology. We use a lot of words that sound fancy. And I'm still learning them. Full transparency, I'm still trying to understand what a lot of it means. And ultimately, what does it actually mean to how that product's going to perform in the field, right? The reasons why crop protection companies use those terms is for a reason. So I'm going to hopefully get us all to a point where we understand the reason for that. And then Katie and I would be remiss if we don't touch on a little bit with resistance management. So Katie will finish us off in that area, of course. So now I'll hand it over to Katie, who's going to talk about our favorite disease triangle.
All right, thanks, Jen, and thanks, Sunny, for the introduction. I would like to clarify that I do not have my PhD. So while I appreciate you trying to take 4 years off my life, I did just do my master's at Michigan State. So I just want to clarify, but thanks. So I cannot do a presentation about diseases without showing you the disease triangle. And so I think it's really important to talk about the basics of disease management and to just really understand why fungicides are used. And so many of you have probably seen this, but diseases do not occur with just a pathogenic organism. So like a fungi, a bacteria, a virus, they need other things in order to occur. And so they need a pathogen, an environment, and a susceptible host. So you know, there are spores everywhere, you know, for some of our endemic diseases, but if they land on, like if an apple scab spore lands on a corn plant, it's not going to cause disease, right? So it needs a susceptible host. And this is also where genetic resistance within that susceptible host comes into play. And so this is often a great angle to manage diseases by taking away that susceptible host. And that's kind of the part of the disease triangle that genetic resistance comes into play. And then there's the right environment. So knowing on your disease triangle what the right environment is for that specific disease is really important. A lot of diseases need moisture. So, you know, when it is a humid, wet year, that is when you see a lot more diseases. But there are some diseases like powdery mildews, which actually prefer less moisture and more humidity and a little bit warmer temperatures. So that's why they're sometimes known as kind of the warmer and drier diseases. But it's really important to kind of understand this basics of what causes disease. And so Jenny, if you want to go to the next slide, we'll just talk about the principles of integrated disease management. And so when you're putting together a disease management program, just thinking about some of these things as you are working through the winter when you're putting together your program. So the number one line of defense for any disease is exclusion. So preventing the pathogen from getting in your field in the first place. And so this can mean a number of things, But, something like the CFIA where there's regulated pests, they're just trying to prevent those from getting into our area in the first place. And so that is really important for some of our serious diseases and serious pests. But this can also include starting with clean rootstock. So if you're planting a new field, starting with clean material, clean seed, just trying to prevent that disease from getting into the field in the first place. It can also come with cleaning equipment for a lot of our soil-borne diseases. The next step is eradication. So this is disease has showed up and you're really trying to eradicate it before it becomes a major issue. So this can be really challenging because they're microscopic organisms and you can't always see them. But it can work in some ways to reduce the disease pressure. So things like removing infested plants as they show up, pruning, hot water treatment, removing alternative hosts, alternative weed hosts. Soil fumigation can be in here. It has its limitations, but really you're trying to eradicate that pest from the soil. Crop rotation, you're looking at eliminating some of those hosts and trying to reduce the disease pressure. Now we're going to focus most of today on protection and specifically on chemical protection. Fungicides have been around and are part of disease management for a long time, starting with the Bordeaux mixture on foliar diseases. But that was actually designed to prevent humans from eating grapes, and they found that it worked really well on some of the diseases. And so we often think of protection as a chemical, but this can also include physical barriers. So if you grow vegetables and you use raised beds, what you're really doing is providing a physical barrier in between the soil and the plant in order to try and reduce some of the disease. And then the last one is resistance. So this comes into play when we're talking about genetic resistance within traits of cultivars. And so this is not always an option, but definitely something to keep in mind when you're looking at disease management. We'll go to the next slide. And I really like this triangle. This was developed by my colleague, Christy Grigg-McGuffin, and it just really shows that integrated disease management is all on top of understanding and identifying that pest properly. And so that's really kind of an underlying factor of all these cultural strategies is understanding your pest, which includes pathogens. And so as you move up, you're really getting up to chemical as an intervention, including biologicals. And they're a really important tool, but they need to be supported by all these other management factors. And also when you're using these other management factors, you can be relying less on fungicides, which is really important when we talk about resistance management a little bit later in the presentation. But it is a really important piece to disease management. And with that, I will turn it to Jen.
Thanks, Katie. So what do fungicides do? Sounds like a pretty simple question. I'm going to talk through 4 different ways fungicides work, right? So one is preventive. You hear people like me talk all the time about applying preventively, but like Katie mentioned, we're dealing with microscopic organisms. So preventive is before you not only see a lesion, but see anything, right? So it's before the plant is infected. It's before we can see symptoms. Unfortunately, most fungicides work this way. So we're trying to manage something before it happens, and the majority of our products work that way. If fungicides work in multiple ways, they often work best preventively. So by best preventively, usually they're more potent. So you get more long-lasting activity if you apply it preventively, or they just are rather weak curative products. That brings us to curative. We hear this all the time. So what does this actually mean? It stops the mycelial growth within the plant. So what is mycelia? So when you have a fungi or an oomycete pathogen, it germinates and grows that tube, right? It's almost like the root of the pathogen. That is how it spreads in the plant. So curative means you're stopping that from happening inside the plant. Still can't see symptoms, right? This is also where what we call fungicides with kickback, which is often used in apple production, right? A term kickback. And there's eradicant. This stops the pathogen during lesion formation. So now we can see symptoms, right? Now, when we're scouting fields, I can see a lesion on that plant. I cannot say this more than I have on the screen. Very, very, very few fungicides work this way, if any, right? Even though this is often how we expect them to work. So what do I mean by that? So if you see a lesion on a plant, it's not the end of the world, right? So if you apply a preventive fungicide on those leaves that don't have symptoms yet, you're probably still protecting them. But stopping that actual lesion you see, our options are pretty limited. Then lastly, there's antisporulent. So like I mentioned, the pathogen, usually you have a spore or like the seed of the pathogen landing in the crop. It then produces this mycelia, or hyphae is often called, and that's like the root. Then that germinates, right? It wants to reproduce again, and that's called sporulating. So producing more spores so it can spread and kill more of your crop. Antisporulent means the fungicide stops that from happening. Again, we can still see symptoms. And actually, a lot of fungicides work this way. But unfortunately, your crop is already infected. So how much of your crop you're going to be able to protect with an antisporulent product is limited as well. So what does this actually look like? So here we have some images of those spores and hyphae or mycelia. So on the preventive side, here we have a spore that has landed on the leaf itself and not yet penetrated into the leaf, right? So that's the big balls you see on top of that leaf surface. Curative, so this image is looking at it as a cross section. So you see the spore sitting on top of your leaf, and this time it has germinated through into that leaf surface. Eradicant, here now you see a lesion forming on, again, these are microscopy images. So you see a lesion forming on that leaf. And then antisporulent, all of those tubes coming up, those are your spores, right? Those are your germination tubes. If we put this into an image, right, a cartoon, so to speak, we have spore germination, infection, mycelial growth, lesion formation, and sporulation. And you can see going from left to right, we're getting more pathogen in the crop itself. Also, by the time we have sporulation, that's when it's bursting through the leaf, and we can definitely see symptoms at that point. Again, most products prevent spore germination. So they stop that spore when it lands on the leaf. You spray the product, it goes on the leaf. Sometimes it moves in, right? But then when your spore lands, it can't do anything. It just sits there. And so if it's just sitting there, it's not really spreading or doing anything to your crop. That's why we always talk about preventive use of fungicides. So now Katie's going to walk through what this looks like with apple scab, which I think is one of the most studied pathosystems in horticulture crops in general, right, Katie?
Yeah, and I was going to say, if you don't grow apples, you're probably tired of us using apple scab as an example for all of these things. But because it is so studied, it is one of the easier pathosystems, so diseases, to kind of demonstrate this idea with, because we really know during that primary apple scab season, when those pseudothecia are releasing those ascospores, we have a very good idea of when that is happening because of temperature and leaf wetness. And so we can really do a good job, in theory, you know, there are other issues sometimes that come into play, of predicting when those ascospores are going to be released and properly applying preventative fungicides. And so like Jen mentioned, this is the majority of our fungicides. This is the way they work. They need to be applied before that spore has landed on that leaf tissue. And so that's when you're spraying, you know, some of those multi-sites early in the season, once you have green tissue and those ascospores are being released. But once that ascospore lands on that leaf and it starts to germinate, there are fungicides that have this kickback or curative action where before you're seeing any symptoms on the leaf, that fungicide, if it's applied after it started to germinate, can help stop that infection and prevent it from going any further and developing spores and whatnot. So this is still both preventative and curative before you can see any symptoms. And then when we get into eradicant use, which again, very, very few fungicides work this way, this is after you've seen lesions in your field on your leaves. in your orchard in that plant. And so it would be sprayed, and you would have some effect on stopping that lesion from continuing and forming conidia, so these other spores. And so eradicants and antisporulants kind of work similarly. It's once you've already seen that disease in the field. And so with apple scab, we also have secondary scab, which can occur if those ascospores have been able to reproduce, so grow and produce their little seeds, which are the conidia. But it works the same way when we're thinking about fungicides. And so when you're thinking about preventative fungicide, sorry, a little out of sync here, but you know, the preventative fungicide still needs to be on that leaf or on that fruit before that spore is able to germinate and infect. But again, you have the same action of curative, that there are some fungicides still before you see symptoms, that once that pathogen has germinated, it can stop that mycelial growth. And then again, once you see lesions on the fruit or on more leaves, that's where a potential eradicant or antisporulant could be effective. But again, you really should not assume that that is what that fungicide is. Assume your fungicide is working preventatively. So I think that's kind of where I'll leave that and pass it back to Jen.
Yeah, one of the things with apple scab we're often asked, right, Katie, is does the product work against leaf scab or fruit scab? Particularly, does it have activity against fruit scab, right? So when we think about this diagram and what Katie just walked us through, how do we answer that question? So when does a product work for fruit scab? It probably has more eradicant activity or antisporulant activity, right? Also, a leaf tissue is different than fruit skin. So the ability of that active ingredient to move into the tissue, which I'll go through later, is also important when we're talking about fruit scab and leaf scab, for example. So now we're going to get into the details, right? So how does a fungicide work? There's 5 things to remember. There's a squirrel outside apparently, and my dog is having a day. So the mode of action, spectrum, the physical chemical properties of that active ingredient, which I'll get into, the duration or length of control, and then the potency. All of these things determine how a fungicide works. First up, mode of action. Here's an example. And we throw around a lot of terminology, and then we say it all means the same thing, right? It all means the mode of action, when in reality, it all means slightly different things. To reduce the confusion, what we have here is an example with Miravis Primes. This is a product from Syngenta with 2 active ingredients. So it's a premix, pidiflumethamine and fludioxonil. The mode of action, so how does it actually stop the fungus? Pidiflumethamine is active on respiration, which if we all remember high school biology, respiration is important for a cell. Then with fludioxonil, it impacts signal transduction. So parts of a cell have to talk to each other, right? And if they can't talk to each other, then that cell can't grow and reproduce. The site of action is the actual biochemical part of that pathogen where it's being targeted. So you've seen the images where you have the site of action, and then you have this cool molecule flying in from the air and it landing in a pocket. This is the pocket, all right? The site of action is the pocket. So pidiflumethamine, it acts on complex 2 of and specifically succinate dehydrogenase, right? So that enzyme. With fludioxonil, it has a bunch of stuff on the screen that we all love to read, right? So MAP, histidine kinase in osmotic signal transduction. So specifically when it comes to water pressure and differentials, right? Then there's FRAC codes. We've heard about group 7s, right? Group 7s, fludioxonil is a group 12. Then the group name, according to the Fungicide Resistance Action Committee, pidiflumethamine falls into the SDHIs. They're also called carboxamides sometimes, just to add to the long list of terms. And then fludioxonil are the phenylpyrols, or the PP group. I have an example here going into botryticides specifically. I chose botryticides because botrytis impacts a lot of crops, right? So here with the animation, what just zoomed in into the cell itself of the pathogen. So if we walk through the different modes of action or sites of action, we can explain where is stuff actually happening in that cell. So here, again, our respiration inhibitors, they act in the mitochondria, and these are the SDHIs. So a couple of examples of non-premixed products, right? So single site mode of actions, we have Circatus and Fontellus that have botrytis activity. And this is across crops, right? So I'm not here giving you a list of all the botrytis products that go on strawberries or blueberries, right? This is just across crops, what collectively has botrytis on its label somewhere. Then we have the terpenes. This is Timurex Gold, and it happens to impact lipid synthesis. So a lot of pathogens, fats matter, right? And having those fats in the cell and balancing them are super important. And this is where the terpenes have an impact. Then we have the APs. So these are often used for apple scab as well, but they traditionally are with the amino acid biosynthesis, so also known as anilopyrimidines. And the one mode of action that we have here is SCALA, right? Then we have the phenylpyrols, which we talked about. So that's fludioxonil. The solo product is Scholar, not used frequently in many crops. Then we have the cell wall biosynthesis. So that's pointing to the cell wall there of the cell itself. And that's a product called Diplomat. The SBI, so SBI, it's like what? I thought this was group 3. So group 3s, right? Also known as the DMIs. This class is divided up into many groups. Some are, but they all impact sterile biosynthesis. So again, fats, right? At the very top, we have the multi-sites. So here I have an example of a biological that acts as a multi-site. So many different Bacillus species. There's Captan, and then Bravo as well is registered in a few crops for botrytis. Then there's premixes. And premixes are not all built equally, right? And this is again a common question I get is, why do you have a premix? What's it for? And Katie will go into that when she touches on resistance management. The one that just flew onto the screen is Luna Tranquility, and you can see it's in 2 different groups. So it's in 2 different groups, and both of those modes of action have botrytis activity. So it's a good resistance management partner. Then we have Mirabis Prime. Again, both partners have activity against botrytis, a solid resistance management product. There's Switch, 2 modes of action again against botrytis, but then things get confusing, right? So we have Maribon here and Inspire Super, both premixes, both premixed for good reasons, but not for resistance management. So they should actually be considered when using them for botrytis as a solo fungicide, all right? So why are they premixed? I know personally with Inspire Super, I registered that product. Why did we add cyprodenil, a group 9, to difenoconazole, which is a group 3? And it's about spectrum, right? What each of those active ingredients do and what they control is different, right? Which has value, right? Then you only have to spray one product. It's not necessarily, though, built for resistance management, which makes everything that much more confusing. We talk about group numbers, and I don't know if what people are more familiar with, either the mode of action like SDHI or group numbers. So now we're going to go through the group numbers. Here we have our M's and BM. BM is basically when it's a biological that is a multi-site. All right. So here, I love multi-sites. I cannot speak enough about multi-sites, and Katie's going to talk about that later, about why multi-sites are awesome. Then we have the group 12s, and you see the color has changed from gray to green to yellow. This is a preview of the resistance risk, right? So group 12s are classified as low to medium risk. They're awesome tools to have in a program to help reduce the resistance risk overall. However, not all fungicides are low to medium risk. These ones on the screen, the 3s, the 9s, and the 19s, they're medium risk. And Katie's going to go through an example of how they need to be managed slightly differently than the lower risk ones. And lastly, the newest class that companies have been developing in is the group 7s, the carboxamides, the SDHIs. They are medium to high risk. Okay, so there's reason it should be not included in the program quite as much as the other groups, right? But they're great tools. So they do work, they're super potent, and there's a reason for using them. We just have to select when and how we use those products specifically. Again, why is this important? It's all about resistance management, right, Katie?
Yeah, for sure. And so both Jen and I had the same advisor at Michigan State. And I was reminded recently of something she said when she talks about mode of action and frac groups. So I really like this because it sticks in your head. But if you think of each frac group like a weapon, you know, if you keep coming at a pathogen with the same weapon, you know, there's a greater chance that they're going to be able to overcome your attack. And so, you know, when we're talking about frac groups and incorporating them into programs, really you're just trying to diversify the number of weapons that you're using. And it is a lot more specific and a little bit more complicated than that, but I really like that analogy because, you know, you can kind of think of your frac groups as your weapons against your diseases. So we'll talk a bit more about this later, but this is why mode of action and understanding it's really important. You need to look on your label for the frac group because it's really important to not just rotate products, but to know what frac groups those products belong into. Because Jen mentioned, you know, there's multiple within the same frac group. So it's really important to know that they're on your labels, often on the first page. They'll have a black box with the numbers associated with them. So it's really important to record that and understand the resistance management strategies around that. And, you know, in general, when you're targeting the same disease, mixing and alternation is really important. And we'll get into a bit more of that later, but you know, that's why this mode of action, site of action, frac group is really important to understand.
So moving on to spectrum, and I touched on this when it came to pre-mixed products, right? So what actually determines the spectrum? Well, it is in fact the mode of action. Certain mode of actions just work against certain species. The chemical structure itself, this has become a very popular thing to talk about. So how that chemical structure binds into that site of action pocket will determine the spectrum. The application rate. There's lots of products that have efficacy against botrytis, but it's at 100 times the application rate that is even registered. So application rate matters. Then there's metabolism. So what does metabolism mean? So essentially when you spray the product onto a plant, that plant starts breaking it down, right? It's natural for that plant to start breaking it apart, breaking it down into different metabolites. The faster that happens will help determine the spectrum. So if you spray a product and it metabolizes immediately as soon as it gets into the plant, it's obviously not going to protect against any pathogen, right? So what are these targets we're talking about? So this is from my global experience working in Basel, and it was really eye-opening about what products we have available on the market and why, right? So this is global usage of fungicides and what's going on what. So 27% of the fungicides used globally are targeting leaf spots. So leaf spots would be, you know, alternarias or early blights, apple scab, for example, which is the picture on the screen. Up next, 22% are used for what's called the omicides. So they're omycete pathogens, downy mildews, phytophthora. This is common in grapes in Europe, which is why it's 22% of the fungicides being used. Then we have the rust. 19% of fungicides used globally are sprayed on rust. And I would venture that the number is much smaller in Canada. So where does this 19% come from? Well, it comes from soybean rust in Brazil, right? A lot of the soy down there is sprayed once, twice, or 3 times targeting rust. Then we have 14% going and targeting what we call the molds. So botrytis, sclerotinia, usually these are the ones that impact quality. So will I want to eat those strawberries? Not particularly today. 11% is used for powdery mildews. 4% is used for Fusarium species. And just 2% is used for bacterial pathogens, right? So looking at this and looking at what products are then developed for these markets, what works for what? So for the leaf spots, thinking about what is available to us, most of them are multisites, strobiluria, and what I call the big three: strobilurians or group 11s, triazoles or group 3s, and carboxamides or those group 7s, right? Those are the main tools we have in the toolbox targeting leaf spots. Things get weird when it comes to downy mildew and Phytophthora. Those products that work for true fungi don't necessarily work for this group. Here we do have, though, the multisites and the strobilurians, and then what I've called specialists. So specialists like Acrobat or Forum, Revis, Ridamil, Presidio, those are really specialist chemistry targeting this group. For the rusts, again, it's the multisites and the big three. Molds, things get weird, right? Here we have the carboxamides working, and then again, specialists. So if you remember that chart or that figure I showed with all the different botryticides, that's actually quite a few modes of action that are all very different working on this group of pathogens. Powdery mildews, here we have the multisites and the big three again, but also specialists. So you'll notice sometimes on product labels, they only have powdery mildew. That's because it's very, very, very specific and doesn't touch any of the rest of this, but it's awesome to have a different mode of action than those big three working against powdery mildew. Fusarium, so far it's only the triazoles and the carboxamides. And then bacteria are the toughest ones, right? There's coppers, some inducers, so they induce resistance in the plant. And then in some crops, we have access to antibiotics, but in general, I think we can't register antibiotics in most crops, right? Because of the concern around resistance with human antibiotics or animal antibiotics. So you can see how this pie is divided up and what mode of action kind of spread across different classes and different groups. Up next is PhysChem properties. And this topic was pretty elusive to me, I would say 10 years ago, and I almost understand it now, right? So it determines how products move in the plant and ultimately, how does it actually impact performance? So does it move up? Does it move down? Does it move through the leaf? Or does it stay on the outside, right? These all impact how that product's going to work, how long it's going to work for, and if it does what you want it to be doing. So what are contact fungicides? Who are they? Here's a big long list. I think I put them in alphabetical order. Most of them, you'll notice, are the multisites. Contact and multisites are not synonyms. Okay? Multisite is referring to how the target site, right? Whereas contact, what does that actually mean? So where does it go? Contact is an elusive term, right? Because when you think contact, contact. However, what it actually means is it lands on the leaf surface and it stays. It does not penetrate into the leaf. That is what contact means. Why does it matter? What's the implications? So we know with contact fungicides, we need good coverage. Typically, you require more frequent applications, and that's because it's prone to runoff, right? Or UV degradation. Formulation quality also really matters. So does it stick on the leaf or does it run off immediately? Up next, the next few we're going to go through are systemic. And systemic is a catch-all phrase that we use to describe anything that's not a contact. So does it move into the plant in any shape or form? In this first example, it's what we call acropedal movement, so up, or xylem mobile. So does it move up in the plant? Who are they? Here I've tried to group stuff together, all right, best I could. So most of the APs, so this is your Inspire Super, in your scala, certain carboxamides, particularly those that have fluopyrim in them, Luna sensation, Luna tranquility. Most of the strobilurins do move. So here we have Cabrio and Quadris, they move up the leaf. And honestly, most triazoles, but not all triazoles. Then Ridamyl Gold. Ridamyl Gold is the classic example of a systemic product that moves up. Where do they go? So again, we have that same radiograph. I didn't explain this very well the last time, but this is looking through the leaf itself. At the top, the dark area, that's the leaf surface. Then we have some wax, and then we have all the bits inside the leaf. So the xylem, the phloem, up and down, right? So first we spray onto that leaf surface. It then moves into the leaf, slowly percolating down, and it moves up the leaf surface. So it protects untreated growth, if that makes sense. Like I just said, what does it mean? It protects new growth. So if you have a leaf and your droplet lands here, it's going to spread and protect your leaf tips. If you have a stem and it lands on the growing point of that stem, it will move into that new growth. This typically leads to longer duration of activity, but there's also some drawbacks because it can also lead to a dilution factor, right? So if we're diluting the active ingredient, it might not last as long. It's typically rain fast within an hour, give or take. And honestly, rain fast studies, it's kind of laughable because often the numbers you get for how rain fast is a product is determined by how quickly can the technician run that potted plant from where it was sprayed into the rain tower. All right. So, you know, I'm saying typically rain fast in an hour. Is it rain fast sooner? Probably, right? Or you see things like once dry. But our limiting factor is that person carrying that potted plant to the rain tower. All right, folks. Up next for systemic fungicides, we have translaminar. Here's the list. All right. It's a handful of our group 3. So Stevia is a new one. Then there's also Inspire Super. You know, Quadris Top also has difenoconazole. And Revis is also a translaminar product, plus most carboxamides. So most of those group 7 products work this way. So where do they go? Again, we have our leaf section, spraying on that leaf surface, percolates slowly through the leaf, and also accumulates on the bottom. So, you know, when you think of a pathogen like powdery mildew, if you're spraying a product that moves translaminarly, coverage doesn't really matter, right? Because you know it's going to move through the leaf. Coverage does matter, though, in the sense that it's not going to move up, right? It's not going to move down. The cool thing is, though, like I said, it covers both, protects both sides of that leaf. You then usually get a longer duration of activity in those treated leaves and stems, and that's because the carboxamides particularly sit in there and don't metabolize for a very long time. Again, typically rain fast within an hour. Then there's the elusive flow mobile products. These are the ones that move down, okay? Who are they? Phos acids, acetyl L, so the alliets, they're really the only ones that move down. Where do they go? Again, spray onto that leaf surface, into the leaf, down to the roots. What does it mean? Foliar sprays will protect against root rots, right? Which is why a lot of these products are used for Phytophthora. They have a shorter duration of activity because they move really fast to those roots, but they are then typically rain fast. Length of control. What determines the length of control? Obviously what you're targeting, how quickly it spreads and reproduces, those phys-chem properties we just discussed, the application rate, and again, that word metabolism. Potency. So this is talking about both duration of control and potency. So going left to right, we're going to increase in duration of control. Here we have the contacts last the shortest amount of time. The triazoles and the strobilurins last 7 to 10 days. Then the carboxamides typically last longer, right? This is all relative. Contacts, why is the duration of control shorter? Washed off, also issues with photostability, so UV or sunlight. The triazoles and the strobilurins, They're very mobile, so you get the dilution factor, and they're also quickly metabolized. With the carboxamides, why do they last longer? Like I mentioned, they bind into that wax layer, and they're also very slowly metabolized. This is also typically increasing in potency. And we know that. You open up a label for Captan, how many kilos are you applying to the crop, right? Compare that to one of the carboxamides like Miravis Duo, it's grams, right? We're not applying kilos, we're applying grams of active ingredient. So it's just showing how as we increase in the duration of control, we're actually also increasing in potency too. So lastly, Katie will finish us off with a few principles for fungicide resistance management.
Yeah, so I mean, a lot of great information on how fungicides work, but we'd be remiss to talk about fungicides without talking about responsible use when it comes to maintaining these products. We know that fungi and oomycetes, the primary targets of these fungicides, are living organisms. And so there have been many, many examples and cases where those organisms from overuse of a certain fungicide can develop resistance. And so what we really want to do with these guidelines and these management strategies is to slow or stop the spread of new resistant pathogens. And so this isn't for existing resistant pathogens, although you can use it if you're using new fungicides. This is for all fungicide use, just to maintain the use, because we know that it takes a long time, and it's also very challenging to develop new modes of action. And so again, these are very general, but I think things to consider when you're putting together a program is you really want to rotate frac groups. So we say it all the time, it's used in herbicides, it's used in insecticides, rotation, 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 very important. In fungicide use as well, we do recommend tank mixing or pre-mixes with multiple frac groups that are active on the same disease. So Jen talked about this, how some premixes are not meant for resistance management for certain diseases. They're meant to broaden the spectrum of control. But when it comes to resistance management, knowing that multiple modes of action are active on the same disease is really important. Also using low risk fungicides. So group M's and the biologicals with multiple modes of actions are really important for resistance management because they can protect some of those higher medium risk fungicides from developing resistance. But again, a lot of these work preventatively. So if you're tank mixing with these group M's or BM's, it's really important to use those preventatively because that's how these are working and then can protect those higher risk fungicides. So in general, if you're using a lot of applications to target a disease, so something like maybe anthracnose in day neutral strawberries or apple scab, it's really important to just try and limit the number of applications per frac group per season. You're just reducing the selection pressure on that disease. Applying preventatively is important for multiple reasons, but I think the main one is that you're going to have a more effective product and you're going to keep that population low. And again, this is how most fungicides work anyway, so you're going to get the desired control. Following label application rates is very important, again, for control, but also for resistance management. And then all the other things around spraying, which is very complicated, but is really important to know what you're trying to spray and making sure that you're getting the proper coverage, especially with these contact fungicides. It's really important because once they're on that leaf or once they're on that fruit, they're not moving. And so it's really important to get proper coverage, especially with these contact fungicides. And so if you're thinking about your risk and you're in a high risk situation because you're spraying a lot on a specific disease, just try and tighten up those recommendations. And those recommendations do change depending on what frac you're using. So these were developed by the Fungicide Resistance Action Committee, and they're updated annually or more than that. So it's this group of experts that get together and look at all the research that's been done and make these recommendations. And so what you'll see here in this chart is the SBIs, so that's mainly the group 3s, the SDHIs, or group 7s, and our QOIs, so group 11s. And so if you're using these in a spray program, What we're kind of trying to go through is the recommendations for using them solo. So when you have a group 3, which is a medium risk, it's okay to use it by itself. It's not really necessary to use it in a mixture. When we're looking at group 7s, which are a bit higher risk, so they're a medium to high, sometimes they can be applied by themselves, but they're a bit higher risk, so are most often like to be used in mixtures. And then when we're looking at a high risk fungicide, like a group 11s, those really are not recommended to be used by themselves when you have a high risk pathogen or you're using them frequently, because they are at such a high risk of that disease developing resistance to them. And then when it comes to alternation, one of our recommendations is always rotate. But with group 3s, it's recommended. If you're using a group 7 by itself, you must alternate. And then when you're using a group 11, you're always going to be alternating. And even if it's being used by itself or in a mixture, you should always be alternating with those group 11s. When we're talking about mixtures, so group 3s, so that first one, not necessarily required. Group 7s, sometimes. Group 11s, always recommending a mixture with that because you're increasing the risk. And so when you're thinking about these different groups, that can be really important. Number of apps, this is the number of applications, number of times you're using this group. So it's not the product, it's the group within a spray program. So with group 3s, we're not as concerned. With group 7s, if it's by itself, 1 in every 3. If it's in a mixture where that other active is active on that disease, 50% is the recommendation. And then for group 11s, again, this is every 1/3 of your applications should be a group 11. And so if you're in a higher risk situation and you're using multiple sprays to target the same disease, just thinking about it in terms of the different groups, because they do carry different risks. And finally, because we get this question a lot, and I think it's really important, is to talk about, is rotation or mixture a more effective option in delaying fungicide resistance? So with fungicides, there's no clear evidence suggesting which is better for resistance management. So we can never really answer this question, but there are recommendations. So of course, use both where possible. But again, some of these fungicides were really limited in the number of modes of action we have in a long spray program. And so the guidelines are, if your number of modes of actions are limited in that crop disease and a large number are needed, use rotation, because you're not going to have the option to mix all of those modes of action and still have a proper rotation. But if you're using few applications for a crop or a disease, you can use a mixture. And so that's why you see in like row crops, when they're applying maybe 1-2 fungicides per season, there are recommendations for mixtures of 2 or 3 modes of action together, but that's because they're not applying 10 applications in a season for a specific disease. And so, in horticulture, it definitely gets a little more complicated because often spray programs are longer and a bit more complicated. And so with that, I think we've covered all the information we want to cover. Hopefully we've left a bunch of time for questions, and I really look forward to kind of this discussion, but there's some of our contact info. And again, our competing strawberry field pictures.
Thanks, guys. That's great. It's amazing how quickly an hour goes by when you're talking about an interesting subject like that. We do have time for questions if anybody would like to put them in the Q&A box there.
Yeah, I do have a couple here and I can address them now. Thank you very much. I just want to remind everybody the pesticide point survey link is in the chat, so please fill that survey link and don't forget to print it or save as a PDF for your Linvo. So the first question is from the chat. So this one is about pollinators and how do these products affect pollinators? I'm not sure which one I want to address, so I just read a question. You guys can decide.
Yeah, so to register a product with the PMRA, there are guidelines for pollinators, and we have to provide evidence that there is or is not risk to pollinators. And so when you look at the product label, I prefer looking at it as a PDF because then you can search it. And so if you're particularly concerned about pollinators, you can search for pollinator or bees, and it will have the precaution on the label. for the most part, fungicides are low to no risk for pollinators because of their site of action. But again, highly encourage you to check the label, because thankfully here in Canada, it's one of the requirements with Health Canada.
Thank you. The next few questions on the Q&A, I'm not sure if everybody can see it, so I'll read a full question so everybody's on it. The first one, for a multi-frag product such as Marius Prime, is the combined resistance that of the best or worst frag group or something different?
Yeah, so that is, I usually take the more restrictive approach. So with Miravis Prime, for example, we have a group 7 and a group 12, right? Is that right, Katie? Too many numbers. See, I even don't like the number system. So essentially you have a low risk product with a medium to high risk product. The low risk, as Katie explained in that chart, really don't come with a lot of recommendations. So therefore you focus on the higher risk. So with Miravis Prime, because it's a group 7 in a mixture with another mode of action, it can be applied back to back. However, we're really only encouraging a single app in a season because we want to reduce the selection pressure on Miravis in general. So yeah, you usually focus on the more restrictive one.
Okay, great. So that's good. Is it always clear from the label if a product is contact or systemic? If not, where can the information be found?
No, and it's a bummer. So we are experiencing, there's guidelines for what can and cannot be on the label at the PMRA. And depending on who the reviewer is, they let us put terminology like that on the label. Sometimes you can find it on the label under the general section. It will describe how that product works. So it will often describe, I wonder if I'm saying that right, the general section. It says general. So again, if you open the PDF, search for general, it'll describe how that product works. And depending on the registrant, it will say more information than others. But reach out to the registrant, so the crop protection company, or your extension specialist like Sunny or Katie, right?
Okay, great. The next question is also about systemic fungicide. As you say, if you hit the leaf, they can move to the tip. If you hit the stem, they can move to the new growth. So how far would you estimate it would go to, and take something like hops that can grow a foot a day? How much of the new growth is protected, and long is that the new growth protected for?
That's a great example. That's a great example with hops, and same with cucumbers, Katie? These crops that grow rapidly, there is definitely a limit, right? If the growth is exceeding the speed that the active moves, you're not going to be protected. Mm-hmm. So often, I'm most familiar with potatoes. I work a lot in potato production, and we call it the rapid growth period. That's when we need to be applying more fungicides when it's putting on that vegetative growth, because the active ingredients can't move as fast. And unfortunately, there's no general rule of thumb. But yeah, with hops, cucurbits, Katie, can you think of another example?
No, I was just gonna say you're also reducing I'm just thinking back to your presentation. The potency is really reduced when you're having that much new growth too, right? So
exactly.
Yeah, so those are very challenging to protect.
That was a very good non-answer by myself, to be honest.
Yeah, and we have lots of questions about systemic function. Oh, Sunny, you have comment?
No, I was just chuckling to myself. You're asking a lot of a product to move with that new growth. And as you say, the dilution factor comes into play there, and the rate of growth. There's a lot of things that we're asking that product to do, and we're asking a lot of that product. Yeah.
Mm-hmm. Okay, another question about systemic fungicide. Can it apply directly to the roots and during irrigation?
So some products are registered for application through irrigation systems. And those products aren't necessarily registered that way because they're systemic. So typically you apply the product to where the disease is that you're targeting. So if you apply the product through drip irrigation or water reel transplant, right, you're trying to protect that root from soil-borne disease. Occasionally, you can apply a product to the soil to give foliar efficacy. One example is with Velum Prime in potatoes. It's applied to the soil in furrow at planting, typically, for control of nematodes or suppression. I don't know if it's control or suppression on the label. Activity against nematodes, let's put it that way. It also has foliar control of early blight in potatoes, and it's on the label, right? So do you use Velum Prime specifically for early blight? It depends on your production system, right? But again, it's applied to the soil to target nematodes. It's systemic and protects against early blight, but that's very rare. It's very rare to see a product label that looks like that. Hey, Katie?
Yeah, I think that's a good point. And like it's registered on now a bunch of other crops, and it has that same like, you know, early powdery mildew suppression. But that's more for awareness. It can have activity early in the season, but again, you're not applying it to the roots necessarily to get that activity, because you can have a lot more specific inactivity if you apply something foliarly for that. But yeah, no, it is interesting because you have some of those phloem mobile, so they're moving with the sugars up to that new growth, and that's kind of, you know, it's rare, but it does happen in some of our products.
Okay, great. The next one is, can you comment on sticker, spreader, same, useful, require, and the importance of pH with fungicides? Very big.
Sticker, spreaders, penetrants. What's the other way they describe adjuvant systems? So there's adjuvants and surfactants. So again, two words that I think mean the same thing. I'm not a chemist, so I'm sure a chemist is wildly offended by what I just said. But stickers, that helps the active land and stay on the leaf. Spread. So typically when you spray, the droplet is like this, right? The droplet on the leaf is a ball. By a spreader, it flattens it. Okay, so that's what a spreader means. And then a penetrant means it helps the active ingredient move into the leaf, either faster, or in the case of onions, you have that waxy outer surface, and we need to get it through that wax. So we often talk about penetrating surfactants to get through the wax itself. So stickers, to stop the droplet from bouncing. I wish I had the video ready. I have a very cool video that shows droplets being sprayed onto a cabbage leaf, I think. They bounce. It's crazy how much they bounce. So the water droplet hits the leaf, bounces, and lands. So a sticker reduces the number of bounces. A spreader, once it's landed, helps that droplet spread out and protect more of the leaf. And then a penetrant helps the active move through the leaf. The second question was about pH. Yeah. So fungicides are definitely impacted by pH, and there's what we call optimal conditions. And I'm not naive. I know we're putting everything in that tank. We're putting fertilizers, fungicides, insecticides in that tank, as well as often tank adjusters, right? Like things that help in that mix stay together. All of that impacts the pH. And sometimes we're putting acidifiers in because that's what's required for one of the components. Recently, I compiled a list of our products, the Syngenta products, and the impact pH has on it. Other companies have that same information as well. In generally speaking, try to stick to more neutral pHs. Going down to 3 is bad news. Going above 9 is bad news too, all right? So, and by impacting the performance, I mean like it'll do weird things in that tank potentially, and it will like antagonize the active ingredient so it doesn't actually work. These things cost too much money for that to be happening. So yeah, reach out to the registrant. They know the optimal pHs of each product.
Mm-hmm. And also read the label. The label would have.
The label often has it as well. Yeah, exactly.
Yeah. Okay, the next question. We have lots of questions coming in. I'll make this quick.
On that same question, sorry, Hugh. On that same question, when should you be taking that pH? Often the pH of your water is a lot different than the pH of your spray solution at the end.
So when do you measure the pH?
Yeah, in practice, most people adjust based on the water, I believe, but.
Yeah, I think the more practical part is adjusting at the water, right, Katie? So what do you think, Katie?
No, yeah, I'd agree. I think that's the safest and most practical way to kind of monitor that. But again, you know, it can change. But yeah, if I ever get this question, I always just reach out to the registrant because, you know, it varies depending on the active and what it's formulated with too, right?
Sorry for interrupting. Go ahead, you.
Oh, that's great, Sunny.
And what do you think of organic peroxide like 0.2 as evidence set for botrytis in strawberries?
What was the product? Sorry.
Organic peroxide.
Oh.
For
Peroxide.
botrytis in strawberries.
Yeah. So peroxide, hydrogen peroxide is that right? Yeah. So hydrogen peroxide is, I think it's classified as a biological, but it's also a chemical, right, Katie? So do you know more about hydrogen peroxide for botrytis?
No, I don't know enough about that product, but I assume it works in the cell membrane. But again, that would work better on a singular spore than it probably would on a lesion. Probably not moving into your plant. But again, I don't know enough about that product.
And what do you think the best product for leaf spot and scorch in strawberries, and how do you know when to apply preventively?
Yeah, so that can be a problem with a lot of the endemic pests and in perennial cropping systems when maybe you have an infection from the year before. But a lot of times when again, Jen mentioned this earlier, when you see a lesion at the beginning of the season, you're still applying the majority of your fungicide preventatively. You know, with fungi and oomycetes, unlike insects, you know, they reproduce very quickly. And so there's often multiple life stages within that field, especially if it's something that's already in there. And so you're still applying it preventatively to most of that population, even if you've already seen some of it. As far as the best product, there are efficacy tables out there. Like I know Erica Pate, who's the Omafra berry specialist, you know, there's a publication that lists efficacy tables. So I'd recommend kind of looking at that or reaching out to your extension specialist.
Yeah.
And local performance information is super important as well. I can't emphasize that enough, right? Katie and I, when we're looking at new products to come and solve minor yeast problems, it's like, okay, what information can we gather from the US? But ultimately we need to prove that it works in the local environment too. Yeah. So that what Katie mentioned about Erica's chart in the fruit publications, they're super helpful guides, and then validate it locally. Yeah.
Yeah. Okay. And another question for hops: do you suggest more frequent application for hops to keep up with the growth?
So I guess a lot of that comes down to, you know, are the environmental conditions favorable for that disease? Like, are you targeting powdery mildew? Are you targeting downy mildew? So you kind of have to keep that part in the back of your mind. You know, is there going to be a big rain? You might want to reapply if it's been a week or a week and a half since your last application. But you really want to think about the disease's biology and the pest biology when it comes to those kinds of things. But you know, when it's new growth and when it's growing really quickly, as Jen mentioned, if the disease is present and you're trying to protect from a specific disease, then yes, that new growth is probably not going to be protected from an application that was a week ago. So.
Okay, great. And the next question, for GH fungicide application to young plants so small in size, can the rate per hectare or the solution concentration rate be reduced?
You're not going to like my answer. It depends. So are you targeting a disease that's in the greenhouse to control it in the greenhouse, or are you setting those plants up for the field? So and often the answer is different, right? So if we're trying to control the disease as it sits in the greenhouse, Usually you spray by dilution, right? So per 100 gallons, per 1,000 liters, whatever the label says. And that's to account for the crop being in the greenhouse, right? If we're trying to protect those little plants out in the real world, right? That's why the labels typically say to spray more product. And I remember, I don't know, Katie, how many hours have we spent trying to translate greenhouse uses to field uses and making sure the product's working? But that's why it's super important to adhere to the crop protection labels, because they were designed for the target in mind, the crop in mind, where that crop's being grown. I don't know, Katie, if you have a different opinion.
It's a great answer. Yeah, no, it's spent a lot of time thinking about labels. I know you guys as crop protection companies have to submit all that information and prove that, you know, the rate that you're applying it at makes sense for the disease that you're targeting and it works on that disease. So that's about as good as an answer as I could give to.
Yeah.
That's good. We are 1:10, and then we still have 2 more questions. I just address these 2, and then we can maybe call in for a day. The next one, what about water quality in a tank other than pH, like total distilled solids?
So water softness will also impact not necessarily product performance, but just tank mix compatibility in general. So I know how we do our testing. We look at very hard water and very soft water to test our tank mixes. And I can tell you, so we do, let's say Miravis Prime. We look at Miravis Prime, hard water, soft water, cold water, warm water. Does our formulation spread very nicely in that water, yes or no? Usually it's yes, because we spend lots of time as formulation chemists building those products. Then we add a bunch of other stuff in the tank. And that's when things go sideways. So water temperature, water hardness, pH, what else with quality can matter? Like the amount of sediment you have in it. Are you pulling from a pond or a well? Or out west, are they pulling from the mountain, fresh mountain water? That's what all my Albertans keep telling me. But it does impact not necessarily product performance, but can you even get it out of the nozzle? And that is such a simple but massive problem sometimes.
Okay. Before I address the last question, I just want to remind everyone that we will send out a survey link for this section after this presentation. So please fill out a section and give us some feedback and any comments you have about our webinars. So the next question, the last question is a more general label question about restricted entry intervals. So how are the IEI times decided? This grower give a very example. So for example, Nova fungicide has a IEI of 11 days for outdoor ornamental roses, but 0.5 days for greenhouses, potted plants, and 2 days for asparagus. I guess it's a more general label and questions to address.
I will do my best to talk about product safety. So when the PMRA does their assessment on product safety and down to the level you just described, a worker walking into an asparagus field versus a worker walking into a multi-sprayed or a multi-picked crop, right? So the re-entry interval is determined by worker exposure. So in an asparagus crop, a product like Nova, you're spraying it to the fern. So who's going to get exposed? So there's going to be field scouts walking through there. There's also going to be the sprayer, right? Presumably in a closed cab. Usually they're in those big tall sprayers now. The asparagus farmers have really expanded. And then, so they do that in the calculation. They calculate what's the risk from an exposure perspective. Then when you look at a multi-picked crop, like cucumbers, how is that crop being handled, right? There's a worker going through every 2 to 3 days to pick that crop. What's the exposure? And then they put it into an algorithm to determine the risk to that worker. That's why REIs differ by crop and often by activity. The brassica vegetables, AKD, for example, often the labels even the re-entry interval is different by activity that you're doing to that brassica vegetable.
Yeah, it's definitely getting more and more specific because, you know, as we get more information about how those crops are actually being used and treated. And I think that's, you know, if I could put in a point here, is it's really important to have accurate use data on how these products are actually being used, what workers are doing, you know, that kind of information. Are you wearing PPE? Is really important for, you know, these kind of products and, you know, making them as useful as possible for growers.
And even updating, eh, Katie? So like farm practices change so quickly to the point that, and things are becoming more and more mechanized. So we may have re-entry intervals that make no sense on our older labels. So if you see that and you question, like, where is this coming from? Just again, reach out to your crop protection registrant, the local sales rep, and they'll pivot into the R&D team to ask, what was the assumptions 20 years ago and versus what's actually being done now. This came through specifically in my experience with the reevaluation for Bravo. The PMRA part of that reevaluation process is saying these labels are old, the assumptions were old. Okay, how are growers actually growing a potato crop now? You know, so it's, that's part of the reevaluation process. But again, if you as growers see something weird, just reach out.
Okay. Thank you so much for the presentation and answer so many questions. I will hand it over to Sunny.
Thanks once again, Katie and Jennifer. Great presentation. You made a lot of light bulbs go off and connected some dots in my mind. So I appreciate you taking time out of your schedule to join us.
Thanks for having us.
Yeah, thank you.
And just share my screen there. Thanks everybody else for joining us. Please don't forget about our next session coming up on February 3rd, the next Farming in a Humid Year session. Why herbicides fail with Dr. Peter Sikkema. The next installment on this year's Getting Into the Weed series. Should you have any questions about this session, please don't hesitate to reach out to me at smurray@perennia.ca. And with that, we'll let everybody go. It's well past the lunchtime in Ontario as well. And once again, thanks for joining us.